Okay, so thank you organizers for giving me this opportunity to talk here. But coming here, speaking on this occasion, the first thing it came to my mind that I would never imagine to have a Rohini memorial ceremony so soon. Knowing Rohini's energy and enthusiasm and all her excitement about physics, and I'm speaking to an audience where Rohini is not present, it seems like unreal to me. So last time when I was here in 2016, Rohini was here, and that was this what is called Indo-French meeting, CPFRA kickoff meeting. Okay. So anyway, so I will discuss mainly my association with Rohini, and while giving two physics paper, I will discuss during my talk. So I joined Rohini as a PhD student in '93 summer, late summer. But before that, one of the students from TIFR, who is a Shubir Sharkar, was an experimental high energy physicist. He told me about Rohini when I got my CSIR, that if you want to do particle physics and there is one person in Bombay University, Rohini Godbole, you can join with her. She is very enthusiastic and she does a lot of good work. So I came to Bombay and met Rohini. And she asked me to meet the next day. And she used to come to TIFR and sit mainly in Sunil's office. So asked me to meet Rohini at Sunil's office in the morning. So I went to see her. Then she handed me around 10 problems in physics, mainly classical mechanics, quantum mechanics, and asked me to solve those problems, and told me to go and sit in the library and solve those problems in, say, a few hours or so, and meet me after lunch. Okay, so I tried my best to solve. Most of them I could solve, but however, 2 or 3 problems I couldn't finish it. So I was a bit scared that what she will talk to and say to me. So I went to Sunil's office in the afternoon and showed the problems to Rohini. And she said, fine. So she then explained to me the problems which I couldn't finish. So then I thought that everything is settled. But the very next day, she came and told me that no, things are not yet finalized. Bombay University faculty members would like to take an interview. So you should come and appear at the interview. So I went next day in the Bombay University Kalina campus, and the then head, his name was Professor Ram Pratap, and he was a solid state physicist. And the interview board, so he was there, and he started asking me questions from solid state physics. Okay. And I was not at all confident in answering solid state physics. So then he asked me, so you have decided to do particle physics from the beginning, you don't like solid state physics? I said, no, I don't like solid state physics. Then Professor Ram, another person was there, is Professor Rangwala. So he came as a savior. Then he has to ask some questions from classical mechanics, quantum mechanics. So he saved me from that. So anyway, so things settled. I joined in October '93 in Bombay University. But the very first day, what Rohini told me that you will have to work with other people, but you may not find me always in the department. Okay. And the situation in the Bombay University physics department was really very bad, infrastructure-wise. Rohini has a small office, a small desk and a chair, and hardly any computer in the department. Most of the computing, if I remember correctly, she used to do in TIFR. Okay. Much later, I think '95 or so, she bought one computer, I think 386 or 486, I don't remember it now. And there was one student in experimental high energy physics group, Sandeep Mangla. So me and Sandeep went there to install that machine in Bombay University physics department. Okay, so this is how it started. And she was not sure about in which direction my research should go. Then she asked me to go to TIFR and attend a set of lectures on quark gluon plasma by Rajiv Bhalerao. So Rajiv was giving a set of lectures in QGP. So I attended those lectures. And prior to joining with Rohini, I didn't have attended any course in particle physics. Then BP was giving a course in particle physics in TIFR. So she asked me to go and attend those courses. So while doing these courses, then one day she told me that there's one person from Kolkata, he would be joining TIFR as a postdoc. His name is Dilip Chaudhary. So we will collaborate with him. Okay. And once Dilip came, and then he gave a set of lectures on supersymmetry. And those days supersymmetry is the beyond standard model physics. So everybody would jump into supersymmetry. So this is what happened with me. So I wrote 4 papers with Rohini. So these are the 4 papers. First one was the Aleph 4 jet anomaly. Then simultaneously I wrote something else, which is unusual charged Higgs signal at LEP 2 with Vishwaroop and Rohini. And then signals of R parity violation at 500 GeV plus or minus linear collider. And the last paper we wrote with Rohini and DP when I was a postdoc in Germany. That was in 2004. So this is the last paper I wrote with Rohini. And after that we had a lot of discussions, but somehow nothing concrete came up. So I will mainly focus on these 2 work that I worked with Rohini. So we initially started a project on the second lightest neutralino pairs, followed by LSP decay by R parity violating couplings in the context of LEP 2. And before that, Rohini, Probir and Xerxes wrote one paper on R parity violating supersymmetric surges. So based on that, so we planned to do this paper. But unfortunately, while we could come up with our results, the Opal collaboration did the detailed analysis. Our plan was also to do the analysis with at the L3 with the Shunondo's help. But I was very upset with this, that my first work, almost 1.5 year hard work has gone to the drain. But Rohini helped me a lot that time. She said, no, don't get worried. This happens in this kind of research things. So anyway, so during this project, I learned a lot of things, basically doing this Monte Carlo calculations, 2 going to 2, 2 going to 3 scattering processes. And those days we used to do Parton level Monte Carlo using Fortran 77. No sophisticated boost, what is called BDT and etc. was not there. So while doing this, around 95 or 96, Aleph collaboration reported an excess over a standard model prediction in E plus E minus going to 4-jet channel. Okay. So what they found is observed 16 events in the data sample of 5.7 picobarn inverse. And that made a stringent criterion search and significantly exceeding 8.6 events predicted by the standard model. So this was the basic feature of these 16 events. Notably, 9 of these events had a 4-jet invariant mass around 105 GeV, while remaining events were consistent with the standard model background. The question is how to interpret this result. But one should note that this only Aleph collaboration had seen this excess 4-jet event. Neither L3, Opal or Delphi has seen that. So we tried first to look into E plus E minus going to a pair of lightest neutralinos, and using this baryon number violating R parity violating coupling, we allowed them to decay into 3, 3, 6 jets. Okay, and then using the jet merging criteria, basically Parton level jet merging criteria, these 6 jets can give rise to 4-jet events. Signal events were too small due to the low production cross section here. Okay, so it is far below the necessary cross section that we need. So we decided to go for the Chargino pair production, which has a somewhat larger cross section than this LSP, because this is a charged particle production cross section. So here again, this Charginos decays into chi1 and then Slepton, and then Slepton decays into 2 jets. So eventually you have multiple jets final states, then you merge the jets and get the 4-jet event. Signal events were in the right ballpark, this 4-jet event, as you can see here. So this is your signal, this is the signal events, and this is the standard model background, and this 4-jet event around 405 GeV. But this is the peak, what you see is the actual events, and this is our event coming from the Chargino pair production. Obviously, because of these 6-jet events, this 4-jet event mass distribution was much broader. So though they fall in the right ballpark, but event shape was unable to match with the observed signal. We get the much broader peak. So at the same time, Debajyoti et al., they studied the same thing, but where they have studied this Chargino decayed into light stop and a bottom, a very light bottom. And from this light stop, they allowed to decay into some hadronic final state. So they have the 2-body decays, and the bottom was so light that you can evade the detection. So they could explain this peak behavior. Okay. So this is thing. And next, what I worked with Rohini, that was in 2004. So this project started in 2003 web in Bombay. So I gave a talk on this evaluating image system, general discussion talk. And that time this project was initiated. So in CP evaluation, we all know in a standard model, it arises in the quark sector, and it was measured from the K-meson decay. However, this CP evaluation in the standard model is not enough to explain the observed baryon asymmetry. So one should look for the new sources of CP evaluation, and MSSM also provides additional sources of CP evaluation. So what are the additional sources of CP evaluation? So they may come from the soft SUSY breaking terms, MI, which is the soft SUSY breaking masses for the gauginos, 1, 2, 3, trilinear scalar coupling, mu. Okay, so these all can have a phases. However, not all the phases are real, but you can redefine the fields to absorb some of the phases. Okay, and the CP evaluating phase mostly taken into third generation to avoid the EDM constraints. Okay. So then one can construct CP odd observables to study these features. This has been studied extensively by these authors. So in normal CP conserving MSSM, you have a two CP even neutral scalars H0 and H, and CP odd scalar A0 and the charge scalar H plus. Okay. Now this tree level CP invariance may be evaluated by the loop effect, where you have this soft SUSY breaking terms. Okay. And then in normal case, you have a scalar and pseudo scalar disjoint, and this part is actually zero in the normal CP conserving case. However, because of the mixing between a scalar and pseudo scalar, you have this off diagonal terms. Okay. So these are a scalar, pseudo scalar, and this is term 2 cross 2 matrix which mixes between scalar and pseudo scalar. So now you don't have exact CP eigenstate here, and this CP this pseudo scalar part is proportional to, goes like phase of the mu and AT, and this is the average mass of this SUSY scale. So basically it is geometric mean of the stop masses. Okay. So now you have the three eigen Higgses, H1, H2, H3, which are the linear superposition of H, A, and heavy Higgs. Now you diagonalize it and you get three eigenstates. Okay. And physical mass eigenstate mixed states and undefined CP properties. And obviously MA is no longer physical parameter, but the charged Higgs mass can be used as a physical parameter. And for the large charged Higgs mass, it decouples and H1 become completely H1 standard model line. So these are your couplings, as you can see here. So this is the additional coupling enters in the gauge boson coupling with the Higgses. Okay, this presence of 3I. And because of this, they also follow certain sum rules. Now in CPC MSSM, we have access to only H and small h and capital H in Higgs-Starling or WW fusion. However, in CPV MSSM, you can produce all three Higgses either from Higgs-Starling or WW fusion processes. And to showcase the effect of CP violation, Carena, Ellis, Pilapsis, Wagner, they wrote a package called CPX scenario. And this allowed the parameter, these are the set of parameters one can tune to get the spectrum of the particles in this model. Okay. So here there is a variation of the couplings, as you can see here with the CP evaluating phase. As you can see here, this is a H1ZZ coupling, which has a maximum when phase is 0. That means H1 is almost CP even. As the CP, this phase of 80 is around 80, this coupling drops drastically, which means the H1 now becomes completely CP odd, whereas H2, which was CP odd here, now slowly gains the CP even component and become maximum at this point. Okay, so this feature was crucial to probe the light Higgs at the LHC that we looked into. Now this set of project CP conserving, you can produce this one, and in CP VMSSM, you can produce all three Higgses in association with the Z and with the WW fusion. And also you can produce all three Higgses in pairs. Okay, so these are the interesting features of this CP violating MSSM. Now, what motivated us to look for the light Higgs window at the left? So this is the standard channel to look for the Higgses. For the low mass, so you can produce H1 and H2, then H1 decays into this H11 and then can give rise to 6 B jets or 6 taus. and efficiency of the so many jets is not good enough to exclude the low mass H1. So there was a window around 20 to 50 GeV still allowed from the Lab 2 data. So we tried to explore this using this model, in this model. And those days, you know, the top and charge risks were very close to DP and Rohini. So they suggested that we should look for this signal using TT bar production. So we looked at this coupling HWH charge risks, large branching ratio for the small tangent beta when top decay into B2 charge risks. So this is the corresponding branching ratios for two values of the tangent beta, and the charge risk mass was less than 148 and MH1 is around 60 to 29 GeV. Okay. So this is the process we studied. So you produce TT bar, so you allow one of the top decay into BW in a standard mode decay. The other one, you allow the decay in the bottom and charge risks. This charge risks decays into W and H1, then W decays either leptonically or hadronically, and then H1 decays into BB bar. So look for WW and 4B events and demand 3 or more tagged B jets. Okay. So the mass of the BB bar pair with the smallest value will cluster around MH1 and BBW around M charge risks. Okay. So this is the basic pattern level cuts we imposed, and the signal cross section we found between 20 to 150 femtobarn for the mass range around 20 to 50 GeV, and the main standard model background was PP going to TT bar BB bar, which is around 0.5 femtobarn after all cuts. So with 13 bars femtobarn data, one would expect this much of a events after all cuts. And remember, these were all done using basic pattern model calculations. Okay. And this is the invariant mass distributions where this BB bar correlation, BB bar and MBWW. And here we didn't take into account any combinatorics. And here, after taking into account combinatorics, as you can see here, this is BB bar. This width here is because of the wrong combination of the BB bar pair. But still it shows a clear peak around 51 GeV. And this is for the charge risks 133 GeV BBW, and this is the top one. Okay. And then Atlas and both CMS, they did some preliminary studies, and this was reported in Lesush 2005. And this is the plot they have studied here. And as you can see here, before cut on MT, and this is the signal background. But later on, I was told that because of the combinatorics and systematic uncertainties in the 4B final state, it was very difficult to probe it at the LHC. Okay, so this is my conclusion. So working with Rohini was a truly rewarding experience. She gave me full freedom to work with others. She was highly enthusiastic and always supportive to me. Her passion for physics was truly infectious, making every decision intellectually stimulating. Personally, working with her was more than just research. It was about developing scientific temperament, learning resilience, and appreciating the joy of discovery. Her loving support and mentorship left a lasting impact on my academic and professional journey. With this, and this is the last email contact I had. We were planning to invite her in IACS to give a colloquium. And on 15th July 2024, she wrote me, I was going to write to you today. I have not been feeling very well, not clear. I can undertake a travel to Kolkata. I have cancelled my trip from 17th to 19th and giving my talk remotely in the conference. You are supposed to come to SN Bose to attend a conference. I will go to Pune at the end of the week. I guess at present we better rethink the colloquium at a later date, Rohini. That was the last email contact I had with her. And this is the photo I took in 2022 at a meeting at ICTS. As usual, Rohini smiling with all of us here, Satyaki, Srirup, Gautam, Devajyoti, Manush, and Diptimoy. Yeah. Thank you.